it wants maximum possible value of C when you take the points Z1, Z2, and 1 over Z2.
Right. What 12? A. It says Z1, Z2 maximum. It wants maximum area. Okay, it is loaded now. Do you know that if we have a root Z conjugate is also a root?
Yeah.
Okay, so is C is a real number, Z2, Z1, Z2 are roots of this. Can you tell me Z1, Z2 are what?
Conjugates. So you can say Z1 and Z1 times Z2 is Z1 squared.
No. Separately. Not product. Z1 and Z2 are equal to what? In terms of C.
In terms of C. Like using the quadratic formula?
Yes, quadratic.
Oh. C plus or minus the square root of C squared minus 40 over 2.
Right?
Yeah.
Okay, so what can we say about delta here?
It should be less than 0.
Yes, why? If it is greater than or equal to 0, we have problem.
Then those would be Z1 and Z2 would be real numbers.
Yeah. So what's the problem?
Then it wouldn't get a maximum value.
Yes, area would be what?
0 would be 0.
Exactly, because real numbers are also complex numbers, right?
Yeah.
So because of this, you cannot say because it's a Z2, Z1 are complex numbers, then we have to, because the area is 0. Now, can you tell me what's the relationship between Z1 and Z2?
Oh yeah, complex conjugates.
They are conjugate of each other, right?
Yeah.
So lengths of them are equal, right?
Yeah.
So lengths of them are equal to what?
Square root of 10, because of Vieta's formulas.
Let's see. C squared over 4, it's real number, right? But because it has I, right? I times something. So you should write minus, right?
Yeah.
So it is 40 over 4, which is a square root, right?
Yeah.
And good job, it is a square root. And then we should try to draw the diagram. We should determine z1, z2, 1 over z1, 1 over z2 in the diagram, in the complex plane, and then you can calculate the area in terms of c. Then you can maximize. Want more hint, or that's enough?
That's enough.
Okay, sure. Try. Want hint, or wanna keep trying?
Hint.
Okay, sure. So, for example, suppose z1 is something like this, okay? Okay. z1 is something like this, right? And z2 is something like this, right?
Yeah.
So z1 is this, z2 is its conjugate. 1 over z1, where is 1 over z1?
1 over z1, I got that to be conjugate. I mean, I got that to be z2 over 10.
Yes, but when we want to calculate 1 over z1, suppose this angle is theta, okay? z1,
Okay.
for example, is REI theta. z2 is what? Polar form of that.
RE negative I theta.
Good job. 1 over z1 is what?
1 over r times
EI,
e to the negative I.
negative. So 1 over z1 is here, right?
Yeah.
And the length of 1 over z1 is what?
1 over r.
Yeah, so it is equal to what number?
1 over square root of 10.
Exactly. So z1 over z1, the angle is negative and it will be something like this, right?
Yeah.
Because this is root 10 around 3 point something. This one is less than 1, right? Agree?
Yeah.
Okay. This one is 1 over z2, right?
Yeah.
Now we should calculate this area in terms of c, right?
Yeah.
It is a trapezoid, isosceles trapezoid. Want hint for calculating this area in terms of c, or want to find it on your own?
I'll do it on my own.
Okay, sure.
Okay, I think I got the answer.
Okay, can you tell me how you calculated the area?
Yeah, so it's a trapezoid. So I said z1 equals a plus bi and z2 equals a minus bi.
Uh-huh.
Then using a and b, you can express the two bases and the height.
Yes. So this one is what? Can you tell me this one is what?
Oh, that would just be a. If
Yes,
z1
what in
is a
terms
plus
of
bi.
c? In terms of c, it is what?
Oh, c over 2.
Exactly. And the area, if c is negative, we should consider this on the left side of y-axis, right? And similarly, we reach same area. So it is c over 2, and this is what? This length.
C c over 20.
Yes, exactly. C over 20. So, now this length is what?
Mm. Oh, 10 minus c squared over 4. I mean, square root of 10 minus c squared over 4.
Why 10?
Because the magnitude of z1 is square root of 10.
So this length is the square root of on. We want to calculate this. We can also use it is imaginary part of z1. So it is 40 because we said discriminant is negative. It is square root of 40 minus c and over 2, but because we consider this agreed or one to it.
Yeah.
This part is this
I
one
agree.
over 2. Agreed?
Yeah.
And you said a square root of 10 minus this inside the square root you consider like that, right?
Yeah.
Okay. So it is this. This length is what?
That over 10.
Exactly. 40 minus. Okay, we don't need to calculate it. So area of this one is what?
C over 2 times square root of 40 minus c squared over 2.
If we want to calculate this area, we should multiply it by what?
9/10.
Exactly. So it would be 9c over. And it wants to find only c, right? So
Yeah.
what is this one? We should maximize this, right? And we consider c is positive, right?
Yeah.
Okay, so maximum of, we can ignore the coefficient, this one, and c is positive, so c is what? So here, how can we calculate maximum of this?
I think AMGM.
AMGM?
Yeah.
Okay, so by AMGM, this one is less than or equal what?
40c cubed minus c cubed over 2.
C cubed?
I mean c squared over minus c cubed.
C squared plus 40 minus c squared over 2 square root of this, square root of this, right? This is 40 over 2, which is 20, right? So maximum is 20. Agree?
How did you get c squared plus 40 minus c squared?
The every x squared plus, or let me write like this, x plus y over 2. Do you agree is greater than or equal to square root of xy?
Yeah.
So it is x, it is y over 2 square root of this times this. You can take it outside the square root of.
Yeah.
It is 20.
Okay.
So c is what?
C is
Equality holds when what?
when they're equal. So
C is equal.
c squared is square root of 20.
So c squared is 40 minus c squared. So c squared is 20. So the square root of 20. And if you see the choices, which choice is the answer?
A.
Yes, but now I want you to find the square root of 20 with 2 decimal digits. Okay? It is what point? So obviously it is 4 point, but what? I told you the algorithm before, right?
Oh yeah.
Okay, so calculate.
I forgot the algorithm.
Okay, let me tell you, pay attention because in some problems we need. Here, you can calculate it. So when you want 2 decimal digits, you should add how many zeros?
2.
4 zeros. For each decimal digit, 2 zeros. Okay. Then from right, you should split 2 digits 2 by 2. Then you say 4 times 4 is 16. Then 4. Then you should add next 2 digits here, zeros. Then we should write what here?
6?
No. Then we have 4. If any number that you have here, you should multiply it by 2.
Okay.
Then we should place what in the circles?
5. Oh, no, 4. 4.
84. Well, 4, 4, 16. We have 1. 4 times 8, 32, 33. So then you place this 4 here. 40. Then here I should 400 minus 336 is what?
64.
Exactly. Then I should add what here?
The 2 zeros.
Then I should place what here?
1 6.
No, look, we have 44 here. You should multiply by
Oh, 88.
80. Then we should place what in the circles?
7.
Exactly, 7. So if we place 7, 7 times 7, 49, we have 4. 7 times 8, 56 plus 4, 60. We have 6. 7 times 8, 56 plus 6, 62. And then 10 minus 9, 1. Here it is not important to calculate because we wanted for this one, but you can calculate 4.46. Check it with the calculator. Is it correct?
Okay. Yeah, it is.
Okay. So we solved this one, problem 22 on, and also we could solve it from here. We used AMGM here, right?
Yeah.
Do you know derivatives? Derivatives, for example, taking derivative here.
Yeah.
Okay, so we can say because C is positive, we can take it inside the square root. So we should maximize 40C minus C, 40C squared minus C to the 4, right?
Yeah.
Okay, so if you take derivative here, it would be 80C minus 4C cubed is equal to 0, right? Then you can divide by C and you can divide by, so 80C is equal, let's write 4C cubed. If you divide by this 20, so C squared is 20, so C is the square root of it, right?
Okay.
Okay, so we solve this one. What's your next question?